Hello everyone and welcome to this segment of the NTI training series. My name is Andrew Smith and I'm the training manager here at NTI. In this particular segment we're going to take a look at the Trinity TI line. We'll look at an overview of the line itself and then we'll take a look at how to properly vent the appliance on a new installation. The TI line is NTI's second generation modulating condensing boiler and it's been in market since 2005. It's available in three different sizes, the 100, the 150, and the 200. We also had been producing a TI 400, but since the beginning of 2009 we no longer produce that model. The 400 is now only available in our LX line. But the TI line provides industry-leading turn-down ratios, with the 100 modulating down to 15,000 BTUs, and both the 150 and 200 modulating down to 25,000 BTUs. And both the 150 and the 200 are also available in the very popular combi units, which combine the boiler with the built-in plate heat exchanger, so in one unit you are able to deliver heat and tankless hot water. All TI units are able to be wall-mounted right out of the box and include a wall hanging bracket. The units are also able to be floor-mounted using the TI floor mounting kit, which can be ordered separately. And now we'll take a look at how to properly install the venting for the TI. The TI line is a high-efficiency boiler line that uses induced power venting. Exhaust gases are to be vented directly outdoors and fresh air is to be drawn from the outside in a balanced system. The TI line requires 3-inch venting material and offers vent lengths up to 105 feet for each the exhaust and the fresh air when using natural gas. This provides for a lot of flexibility when determining where to locate the boiler and where to terminate the venting system. When installing the 150 or 200 using LP, this maximum length is reduced to 50 feet. Because elbows add resistance in the venting system, each elbow is considered equivalent to 5 feet of pipe, and this is for any kind of elbow, be it a 45, a 90, a sweep, etc. There's a chart in the installation manual similar to the chart on this slide that shows how long your venting can be based on the number of elbows you are using. For example, if you were installing a TI 150 using natural gas and you had 5 elbows in the venting system, the chart above would tell you that you can run that venting system a maximum of 80 feet in order to allow 25 feet of equivalent length for the 5 elbows and still not exceed the 105 overall equivalent length maximum. Material used for exhaust venting must comply with ULC S636, and this applies to the exhaust pipe, fittings, and cement. As per the code, all applications in which the flue gas temperature may exceed 65 degrees Celsius, or roughly 149 degrees Fahrenheit, exhaust venting must be done with S636 CPVC. Only in applications where you are certain the flue gas temperature will not exceed 65 degrees Celsius can S636 PVC be used. In all other applications, the code states the use of CPVC is required. Material used for fresh air supply can be PVC or ABS, and it's important to remember that the length of one vent pipe, either the intake or the exhaust, cannot exceed the length of the other by more than 20 equivalent feet. For example, if your exhaust run is 60 feet in equivalent length, your air intake needs to be somewhere between 40 and 80 feet of equivalent length. The fresh air intake on the TI is located on the bottom of the cabinet, and you'll notice that inside the cabinet the venting material is 1.5 inch. So included with each boiler is a 1.5 to 3 inch adapter to be used for the fresh air intake, and that adapter should be attached right at the cabinet. Do not extend the 1.5 inch material beyond the cabinet, then eventually go to 3 inch. We want you to use that adapter right at the cabinet so that all venting outside of the cabinet is 3 inch. The exhaust goes off the top of the boiler, and you'll notice at the top there's a 3 inch male PVC fitting. This requires a 3 inch coupling, which is field added, to connect to the exhaust venting material. Because the flue gas will condense in the venting system, it's important to make sure that the exhaust venting is pitched back to the boiler at 1/4 inch per linear foot. This is to ensure that condensate doesn't collect in the venting. We want to make sure it all flows back to the boiler and out through the condensate drain. If you have a long horizontal run on the exhaust vent, you may want to consider increasing the pitch to 1/2 inch per linear foot to ensure proper drainage. Because the horizontal venting material needs to be pitched back to the boiler, we recommend the use of a swing joint. This means that instead of just going vertically into a 90-degree elbow, then horizontally from there, you instead use two 90-degree elbows as indicated in the diagram on the slide. The reason for this is that without the extra elbow, when the horizontal pipe is pitched, it causes the vertical pipe to be thrown off vertical and strain is placed on the connection at the top of the boiler. Instead, if you go vertically off the top of the boiler into a 90-degree elbow, then horizontally with your venting into another 90-degree elbow, the horizontal piping can be pitched back to the boiler without affecting the vertical pipe. Once the horizontal pipe is at the proper pitch, the two 90s can then be glued together. Running the venting on the exterior of a building is okay, but there are a few requirements to keep in mind when doing it. The maximum length on the outside of the building is 20 feet, and that length needs to be included in the overall equivalent length calculation. It needs to be sloped back to the boiler at a rate of ½ inch per linear foot versus the ¼ inch per linear foot that we discussed earlier, and it needs to be supported every 24 inches instead of 36 inches for venting inside the building. Anything over 5 feet in length needs to be insulated. When using a two-pipe termination through the sidewall, this is the configuration required. The fresh air inlet goes through the wall and into a 90-degree elbow pointing straight down. The exhaust vent goes through the wall and into a 90 pointing straight up, and then into another 90 pointing straight out. This means that there are 3 elbows used to terminate the venting on the outside of the building, and those 3 elbows do not need to be included when counting the total number of elbows, as they're already factored into the 105-foot equivalent length maximum. We also include bird screens with the boiler that should be used. It is important to ensure that proper clearances are maintained when using a two-pipe termination. First of all, the fresh air intake needs to be at least 12 inches above your local snow allowance. If you don't know your local snow allowance, you can typically consult your local weather office. And the exhaust outlet needs to be a minimum of 18 inches above the fresh air intake and spaced a minimum of 4 inches horizontally from the fresh air intake. In other words, don't place the exhaust directly above the intake. Make sure there's at least 4 inches of horizontal separation between them. If you space them more than 12 inches apart horizontally, you'll need to increase the 18 inches of vertical separation between them as well. For every inch greater than 12 inches they are spaced apart horizontally, you'll need to add an inch of vertical separation. For example, if they are 18 inches apart horizontally, you'll need to add 6 more inches of vertical separation to the original 18 inches, so you need to make the exhaust 24 inches above the intake in that example. Regardless of how far apart you have them spaced horizontally, the vertical separation will never need to be more than 3 feet. There are several options on how to terminate the venting, and one option that we've already covered is through the sidewall, but you can also terminate through a roof or through a vacant chimney. In the case of terminating through a roof, the same clearances pertain in that the fresh air inlet must be at least 12 inches above snow allowance, and the exhaust needs to be 18 inches above the fresh air inlet. Also be sure to point the terminations away from the slope of the roof, and make sure that adequate flashing is used where the pipe enters the roof to prevent water leakage. Running the vent pipe through an existing chimney is okay, as long as the chimney is not being used by any other appliance, flue gases don't enter the chimney, appropriate venting material is being used, and the vent lengths don't exceed the maximum specified. Also, when using a chimney, you need to make sure you install and seal a rain cap. Another option is the use of concentric venting. However, in Canada, the concentric vent kit available from NTI is not able to be used because it is not CPVC. There are CPVC concentric vent kits available from other manufacturers, though, so those are able to be used on the TI 100, 150, and 200. The TI 400 is not certified to use concentric venting, but there is a termination kit available for that model. When venting through the sidewall with a concentric kit, be sure to leave 1 inch between the wall and the vanes of the vent cap. When venting through the roof with concentric, leave 24 inches of clearance on the upslope side of the roof and ensure the roof penetration is properly flashed and sealed. When venting multiple boilers using concentric vent kits, the terminations need to either be placed closely together or spaced far apart, so either within 4 inches of one another or at least 24 inches apart. Either one will ensure no cross-contamination, but anything in the middle may lead to either combustion problems or potential freezing. And that concludes this segment. And on behalf of everyone at NTI, I thank you very much for your interest in our product, and I hope this segment was helpful for you. Thank you.